Okay guys, today we are going to be doing some work with rational expressions. So we're kind of laying the foundation for stuff we're going to do later in the chapter. So we're really going to focus on how to find excluded values, how to simplify, and how to find LCDs. So we're going to start with a excluded value. So in math, you're not allowed to divide by 0. So just a friendly reminder of what that looks like in a fraction. I like to give students this example. It's okay to have a 0 in the numerator. Do you see how that 0 is there? That's okay. It is not okay to have a 0 in the denominator. Okay? So if you look at this first example right here, what would make this entire denominator 0? So what value of x would make that 0? So if you're ever not sure, all you can do, or all you need to do, is just set it equal to 0. So x plus 2 equals 0. That's what's going to make it 0. Subtract 2, x equals negative 2. What that means is, if I were to plug negative 2 into this equation, negative 2 plus positive 2 would make 0, which would then make us have the 0 in the denominator, which is not allowed. So instead of saying x equals negative 2, we're just going to put a line through it and say x cannot equal negative 2, because that's the excluded value. Okay? Let's go ahead and take a look at the next one. So we're doing the same pattern. So sometimes you guys are asking me for steps. How do we know how to do it? So the step for this one, what you need to write down is put the denominator equal to 0. So whenever you want to do this, set denom, so denominator, equal to 0, and solve. So we get to use the factoring from last chapter to be able to do this. So this was one factor. X plus 2 is an entire factor. And then this one is our next factor, but this is actually not a factor. This is 3 terms. And so what we're going to do is, we learned from last chapter, if it has 3 terms, we're going to t-chart it. So just doing the math real quick for that. Multiplies up to give me x squared, multiplies up to give me 3, and then cross multiply, 3x plus x is 4x. So I have the right one. So instead of writing this in standard form, this is standard form or expanded form, I'm going to write this in factored form. So in math, a factor means you're using multiplication. So here's where the multiplication is happening, right there between the 2 parentheses. So now what we're going to do is split set, see what you get. So what value of x is going to make this 0? So 0 times anything equals 0. So we're kind of just splitting these up into 2 pieces. X plus 3 equals 0, and x plus 1 equals 0. Subtract 3, so negative 3 makes it 0, subtract 1, and negative 1. So instead of saying you can equal those, we're going to say you can't equal those, because then you'd have a 0 in the denominator. Sometimes students will ask me, like, well, what about this guy in the numerator? It's okay for that to be 0, so we don't even need to look at it. We're just strictly focusing on the denominators in these ones. So that brings us to C. So same thing, we have x times x minus 2. This is already in factored form because we have x times something. So what we're going to do is set each piece equal to 0. So we have x equals 0. 0 times whatever this would still be 0. That's the 0 product property. 0 times anything is still 0. And then we have this one, and I would get x equals 2. So instead, I'm going to say x cannot equal 0 or 2. Okay, so that's our answer for there. So again, why can't it equal 0? Because those values would give us zeros in the denominator, and you cannot divide by 0 in math. If you want to know why, you can watch a YouTube video on it. Okay? Alright, so that was that part. The next thing we're going to do is simplify the given expression. So in math, the way you simplify is you cancel factors, and that's what we're going to be doing. There's other ways to simplify, but for this particular problem, we're going to cancel factors. So in order to be able to cancel factors, we actually have to factor. So all of these are in expanded notation or standard form. They have not been factored out. So that's why last chapter was on factoring, so that we could progress into this chapter. So I'm actually going to start with C, just so that we can see this one, because I like this problem. So I'm going to factor both the numerator and the denominator. Why do I need to do both? Because I'm no longer just looking for excluded values. I have a different set of directions. So here is my numerator t-chart. So 2x and x, and I have more negatives, and I have 7 of them, so I'm probably going to have to make that. So that's negative 8x, and that's 1x, so that works. So my numerator factors to 2x plus 1 times x minus 4 all over, and let's do the t-chart for the denominator. We have 10x squared, 7x, and 1. So I know this has to be 1 and 1. So if I put 10x here and x here, that would give me 10 plus 1 is 11, and I want 7. So it's probably going to be like 5x and 2x. So that would give me 5x when I cross multiply. That gives me 2x, and when I add them together, I get 7x. So that's perfect. So then I have 5x plus 1 times 2x plus 1. Now, in order to cancel, you have to have the factors be in common. So I can cancel this, and I can cancel that right there. But I cannot cancel this x with this x, because they are grouped together. So the answer to this one is x minus 4 over 5x plus 1. So you, again, when you have a plus or a minus, that's a family. They're stuck together. I was only able to cancel those because it was the same family, and therefore they could go on vacation together or something. I don't know. They could be canceled out. But I can't cancel this x with this x because this x is grouped with this 5 and this plus 1, and this x is grouped with that. So if you actually gave me an answer with parentheses, because I strongly encourage parentheses in this unit, I would give it to you correct. Mathematicians are lazy and don't like to write extra symbols, so they would probably write it like this. But if you did this just to solidify in your mind that you can't cancel those because those are common terms, not common factors, I would still give you credit. Okay? So now we're going to go back up to part A, just because I want to move on to this one right here. So this one doesn't look like you can factor it. We're going to be able to factor it, but what I'm going to do instead is I'm going to start with the denominator. So I know because it has 3 terms, I'm going to t-chart, and then I need positive 2 and negative 8. So let's see, sorry, positive 2 and negative 8. I said that right. Okay, that works. So I'm leaving a line for the numerator. I'm going to get to that in a second. Right here I have x plus 4 times x minus 2. So if this is our numerator, do we have any family that's exactly the same? And you're like, well, no, at negative x minus 4 isn't the same as x plus 4. But the reason why we're going to be a little careful here is if I pull out a negative 1 from this, So that's as if I was doing hockey stick with -1. So we talked about hockey stick or GCF last chapter. So -1, this would just be x, and what's -4 divided by -1? That's +4. So there is an x plus 4 kind of hidden in there. And now I have the same families, so I can cancel them out, and they're going on vacation. And the leftovers that have to work or something, I don't know, that's a bad analogy. This is our answer right here. Okay? Alright, so let's try that with this one. Do you guys see that both of those are negative right there? So I can factor out a negative. They actually both have a -3 in common. So if I pull out that -3, what would be left? So just do this. -3 divided by -3 is 1, and -3x divided by -3 is just 1x. I'm going to put a dot like that because it's normally you don't put the 1 in front of the x. If you want to, you can. So my numerator factors to -3, which is this piece from my hockey stick, to 1 plus x. And then how many terms are in my denominator? 1, 2, 3. So I'm t-charting again. So I'm just going to t-chart this one real quick. So we have x squared minus 6x minus 7x, x, -7 and 1. I know it's going to be -7 because the 6 is negative, so I need more negatives than positives. But I always like to check here. -7x plus x makes -6x. Now I have x minus 7 and x plus 1. So the question is, are these the same? Like, they kind of look the same, but we're not sure, so are we allowed to cancel those? So the answer is, as long as you've checked to make sure every term has the same sign, then you can cancel them. So 1 is positive, and 1 is positive here, and x is positive here, and x is positive here. So they are, in fact, the same factor. So we can cancel them, and then this is our final answer. Whoa, I didn't leave myself room for that answer, did I? It's okay, I'll write it down here. -3 over x minus 7. Again, you're more than welcome to leave parentheses around the family so that you keep in mind that you can't cancel it unless they're a common family, and that's an option for you there. Okay, last little thing in today's lesson is called the LCD. This is something you guys did way back in grade school. So we're going to go over the definition of it real quick. The least common denominator is found by factoring each denominator and finding the least common multiple, or LCM, of the factors. Here it is broken down step by step. So first thing you're going to do is break this down into factors, and then the next thing you're going to do is list the different factors. If the denominators have common factors, use the highest power of each common factor. So I'll show you guys how to do this. Now, keep in mind, this is called the least common denominator, so we're focusing on our denominator. So here, if I need to find the LCD, I'm going to start with actually problem B. I like B. So let's start there. I'll go back up to A, but I think this one is more basic, so it makes more sense to me to start with this one. So 7x and 21, they have a 7 in common. 7x divided by 7 is x. 21 divided by 7 is 3. So these are the factors. 7 is a factor, and x plus 3 is a factor. When you multiply factors together in math, the answer you get is called the product. Just like when you divide, you get a quotient. When you multiply, you get a product. Okay? So over here, I have 2 times x minus 4. And how did I get that? They both are divisible by 2. 2x divided by 2 is x. -8 divided by 2 is -4. So if I want to find the LCD, I'm going to list all the factors, so they have to be different. So this is 7, great. This is x plus 3, great. This is 2. Great. And x minus 4. And then I'm just going to multiply them. So that looks really simple, right? You just find all the factors and write them down. Well, that's the most basic one, so that was pretty simple. So the LCD would be 14, because 7 times 2 is 14, times x plus 3 times x minus 4. And that is our LCD for that one right there. Okay, so let's practice in C before we move back up to A. Okay, so looking at letter C, 12x plus 60, 12 goes into both of those. 12x divided by 12 would just be x, and 60 divided by 12 would be plus 5. And then over here, what is that? Oh, we got a T-chart. Let's check out that T-chart. Just takes a second. And I get x plus 5 times x plus 3. So now what you're going to do is write the LCD. So we have LCD. It's going to start with 12. That one has a 12. Okay, you're like, great. The next one is x plus 5. Okay, great. Well, the next one is x plus 5, and it's to the first power. If we already have an x plus 5 to the first power, we do not repeat this one just because it shows up here. We only write it once, okay? So let me say that again. If you're going through and you're like, okay, there's a 12, put the 12 down. Now there's an x plus 5, put the x plus 5 down. Oh, this one has an x plus 5. Well, if it's already in here, don't write it again, okay? Especially because they're both to the first power. And then this one needs an x plus 3. So that's our LCD for that one. So we just progressed a little bit to learn about what happens if they have a factor in common. You write it one time, okay? So both of these should be incorporated into this. 12 is in here and x plus 5 is in here. And then for this one, the x plus 5 and the x plus 3 is in there as well. Okay? Now we're going to go back up to A. And on part A, we're going to do our factoring. So 8 goes into both those, right? So 8 goes into 8x divided by 8 is x, and negative 24 divided by 8 is negative 3. And then over here I have 10 times x minus 3. Okay, so when I go to do my LCD, I need to actually be careful because this number 8 is actually broken down even further. I didn't break it down all the way. So I'm going to pause and just reference this problem we did down below when I did 7 and 2. Can you break down 7 and 2 anymore? No. So that's why I didn't do it here. And then here, I could have broken down 12 into 2 times 2 times 3, but because there was no other number here, it wasn't necessary. We're going to see why it's necessary in this problem to break it down if there's other numbers. So 10 is 2 times 5. So what you're going to do is the LCD, you're going to start with the first one, and it needs a 2 times 2 times 2 times x minus 3. Okay, so that's all of those guys are in there. Now I'm moving on to the next one. Is there a 2 in here for this guy? Yes. There's actually 3 of them. This guy only needs 1. It's this guy that needs 3. But we're already going to say, you know what? This guy has you covered. So you don't need to write another 2 because there's already a 2 in your LCD. Is there a 5 in your LCD? No. So we're going to make sure we put the 5 in there. And then is there an x minus 3? Oh, there already is one, so I don't have to repeat it. Okay? Now we're going to do the math. What's 2 times 2 times 2 times 2 is 4, times 2 is 8, times 5 is 40. So the LCD for this one is 40, because that's all the coefficients, times x minus 3. Alrighty, last one is this one down here. So this one, we are going to t-chart each of these. X squared, negative 12x, 35, x and x. It's a positive 35, but negative 12, so both of these must be negative. So let's see, negative 5x and negative 7x. So we have x minus 7 times x minus 5. And so right away, you could actually do this even. Once you factor the first one, you can be like, okay, there's the first part of my LCD. And then the next part of my LCD is going to be what I get from this, maybe 3x minus 40, x and x, and then it's positive, so probably like that. So sometimes students ask me, how come I'm so fast with my t-chart? Guys, I do this for a living, so like math and numbers just come into my head quicker than they're going to come into yours. That just makes sense. We'll just accept it. But also what I'm doing is just recognizing patterns. This is negative 40, and this is a positive 3. So I know that my two numbers here, the bigger number is going to have to be positive. So I could have picked 10 and 4, because that will also make 40. But if I add 10 and 4, I get 14, and I subtract 10 and 4, I get 6, which is not the 3, so I knew it wasn't going to be that. So this one does work out. So this one is x plus 8 times x minus 5. So here's my first LCD. Then I'm saying, is there already an x plus 8 in my LCD? No, so I write it. Then I move on. Here's x minus 5. Is there already an x minus 5 in my LCD? Yes. Okay, I don't repeat it. So this is my LCD for this problem here. And that is all that we have to worry about. Alrighty?